Let's try calculating f prime of x using the limit definition. So for this example, let's say f of x is equal to 3x squared minus 1, and the problem is to find f prime of x using the limit definition. So there's our problem. To get started with finding f prime of x, let's remember the formula. So f prime of x is equal to the limit, as h goes to 0, of f of x plus h minus f of x all over h. Now remember that f prime of x here is just another way of saying slope of the tangent line. So what we're doing in this problem is we're finding a formula for the slope of the tangent line to this particular curve. Now to get started with our calculation, let's write down our limit sign again. And we'll start with the numerator here. To figure out f of x plus h, we're going to have to replace all the x's that we see here with an x plus h. So we'd have 3 times x plus h all squared minus 1. So these two terms give us our f of x plus h, and then we're going to have to subtract off f of x exactly as it appears. Now because there's more than one term here, we're going to have to give ourselves some big brackets here. We want to make sure all of 3x squared minus 1 really does get subtracted off. And then we're going to take this whole thing and divide by h. Now, if we were to try plugging in h equals 0 here, what we'd find is that we'd have 0 on top, 0 in the denominator, so we'd have 0 over 0, and that gives us a clue that we need to keep going, we need to keep doing some algebra here to make sense of this expression. So for our next step, again, we'll copy down our limit sign, and we're going to try to expand out this numerator. So we can deal with the square first. We'd have x squared plus 2xh plus h squared, and then we're going to subtract 1. And at the same time, we could multiply through the second bracket here, multiply through by negative 1. So we'd have minus 3x squared and then plus 1. And that is still all over h. All right, so again, if we tried plugging in h equals 0 with a little bit of work, we could check, we'd have 0 over 0, and so we need to keep going with the algebra. Now, one thing you might notice before we go on to our next step is we do have a little bit of cancellation here. So we can cancel, say, the negative 1 and the positive 1, and that will speed up our next step a little bit. So going on to the next step, we've got limit as h goes to 0. Let's expand through this first bracket here. So we got 3x squared plus 6xh plus 3h squared. And then we've got our minus 3x squared there, and that's all over h. So again, we get a little bit more cancellation. The 3x squared and the minus 3x squared are going to cancel. Again, if we tried plugging in h equals 0, we just have 0 over 0, so we need to keep going with the algebra. So for our next step, we might notice in the numerator here that both of our terms have an h in them. So let's factor out that h and make it h times 6x plus 3h. And that is still all over h. Now, what this allows us to do is just cancel the factor of h on top with the factor of h on the bottom. And remember this denominator here, you can really think of it as h times 1. So when we cancel out that h, we're really just left with a 1 in the denominator there. So we've now got 6x plus 3h all over 1. Now this is the very first step where it actually makes sense to plug in h equals 0. For our next step here, we do not need to write down the limit sign now. We're actually going to plug in. We're going to evaluate this at h equals 0. And what we're going to have is 6x plus 3 times 0. So final answer, just 6x. So remember, at the step where you plug in h equals 0, you can stop writing your limit expression. So now what we figured out is that the slope of the tangent line, m tan, at any point along this curve here is equal to 6x. So let's draw a little sketch just representing this idea here. We make a quick sketch of f of x equals 3x squared minus 1. Let's plot a few points here. So when x is equal to 0, our y value is going to be -1. And if we plug in either x equal -1 or x equal +1, we're going to get a y value of 2. So that gives us 2 more points on our curve here. And this function here is just a nice parabola. So we have something looks roughly like that. We can label our axes here and just indicate our scale a little bit on our sketch. So there's our function. And now what this f prime is allowing us to do is we can plug in any x value that we like here. So say f prime of 0. Going back to our formula here, it's going to be 6 times 0, or 0. And what that's telling us is if we locate the x value 0 and we draw a tangent line at that point to a curve, tangent line is going to look like this. This is giving us the value of the slope of the tangent line. So it's just saying slope of this tangent line here is equal to 0. So that makes sense because our tangent line looks horizontal there. So yes, the slope should be 0. If we plug in another x value, say x equal 1, f prime of 1, according to our formula, is going to be 6 times 1, so 6. And if we locate the x value, x equal 1, be that point right there on our curve, we could draw the tangent line to that point on our curve. Might look something like that. And so this little formula here is just telling us slope of that tangent line there is equal to 6.